for programming IPv6 software. This is a design choice. Keeping a single socket was easier, and having two sockets wouldn't solve the issue anyway. Okay, and we designed a new structure. It's called AST sock adder. That's for keeping a sock adder storage and the length of the socket together. So we have only a single structure to pass around functions, and we can never lose the two components. That happened in our first version because we didn't do that. In our first version, we just modified every single function to take a length, an additional length. Sometimes we were lazy. Sometimes people changed the code upstream, and when we merged, we forgot to add the new parameter to the new functions. So having a single structure made it much easier and much easier to keep in sync also. And we chose in that structure to use sock adder storage, not a union of sock adder in and sock adder in6, for two reasons. Unions, when you need to, you really need to know if it's an IPv6 or an IPv4 address. Sometimes you do need that. So you will be casting the sock adder storage into the type that you need. When you're doing that, casts are very ugly and they generate bugs. So we want them to be explicit, we want them to be ugly, okay? So that you can see that there's a cast in the code. If we had been using a union, cast would have been implicit. So it would have been hard to grep. It wouldn't have been greppable. And the second reason is that the union would impose a predetermined set of address families. Right now, we cannot imagine supporting something other than IPv4 or IPv6, but we never know. If that ever happens, we'll be ready then. We already support IPv7. So we factored all the network code in ChanSIP. We factored it into NetSoc2. There was already a NetSoc module. It wasn't used very much in ChanSIP. It was used in other channels, which we haven't touched yet. We created a new module, a separate module, so that existing channels, which we haven't converted yet, could still keep using NetSoc. NetSoc2 is completely separate from NetSoc, and it's the only one you should be using in a channel that has been converted to IPv6. It also contains address and URL parsing and serializing. We replaced all the uses of sock adder in and data structures with AST sock adder. That was straightforward. We used the new AST sock adder API function calls. We have many such functions which we will go through. And we have some cast functions that we used in modules. For example, the RTP subsystem had to be converted, so channels that use the new RTP subsystem use some cast functions. We converted ChanSIP, Chan Multicast RTP, ACLs. ACL wasn't done by us, by the way. It was done by Digim. DNS Manager, TCP TLS, RTP Engine, RTP Multicast, and RTP Asterisk. This is what has been ported. What has not been ported is every other channel. The stun subsystem, which is used by ChanSIP, has not been ported since there is no NAT on IPv6. It would be useful for ICE for doing connectivity checks, but the stun subsystem that's in Asterisk now isn't suited for that. The manager cannot listen on IPv6. The HTTP server cannot listen on IPv6. And any GUI out there, we didn't touch that. We get asked this question many times. If you use a GUI, it's probably not going to support IPv6. So this is the structure in question, AST sock adder. It contains two members, sock adder storage and sock adder length. In the code, the indentation is perfect, don't worry. And we have functions for parsing, stringifying, resolving, comparing addresses, and some wrappers around BSD functions so that you can use the BSD functions as if they used AST sock adder. For example, parsing addresses. Here, for example, we have a function called f that takes a string and it parses it And the string can contain either an IPv6 address, an IPv4 address, an IPv4 address with a port, an IPv6 address with a port. The IPv6 address, if it doesn't have a port, it may or may not have brackets. It's all supported. If you want to restrict the set of these possibilities that I just enumerated, you can use flags. And these are the few flags that we support. It's fairly straightforward, I think. For serializing addresses, well, it's all very straightforward. This is, when given an address, AST suckaddr stringify is going to produce either the address on the left for IPv4 or on the right for IPv6. If you only want the address part, you don't care about the port, you can use AST suckaddr stringify adder. If you want the IPv6 address to have brackets, then you're going to have to use stringify host. We called it host because it means it's the host part of a URL. And if you only want the port as a string, you can use stringify port. And all these functions, the pointer to the string that they return, the string is on thread-specific storage. And all of these functions share the same TSS, chunk. So if you, for example, it forces you to be smart. If you try in a single printf statement to print the address and the port separately, it will fail because the two functions will be called, they will overwrite each other, and it will fail. What you need to be using is stringify adder or stringify, so it's a bug and a feature. We're not changing it at all. If you want to resolve addresses, you're going to use AST suckaddr resolve. It will return a linked list of AST. Is it a linked list? No. It's going to return an array of AST suckaddr. And you're going to iterate on that array. AST suckaddr resolve uses getAddrInfo underneath, just like parse did. So it has the same flags. And it has an additional parameter that lets you filter results. If you want, for example, to only get quad A records, you're going to use AST-AF INET6 to get only IPv6 addresses. Okay, so what's the difference between parsing and resolving? Well, when you're parsing, it's not going to make DNS requests. It's only for numeric representations of addresses. When you're resolving, you might be doing DNS queries if needed. So resolve is going to be returning multiple addresses, whereas parse will return only one address. So parse really is a specific case of resolving. We created parse because it makes it easier to use in code. You just don't need to have a for loop. And the best practice is to iterate over the results. Do I need to reiterate that? It's really, really important. And Chansit doesn't do it now. That's also a big architectural change that would be needed. And we didn't address that because it's, again, not related, not specific to IPv6. You would have the same issue with IPv4 if you had multiple A records. Am I out of time? Soon, okay. These are IPv6 mapped IPv6 addresses. These are the addresses that never appear on the wire, but are used to communicate between the kernel and the application. When an application only has an IPv6 socket, and it also wants to listen on IPv4. And we need to handle these addresses in Asterisk. So we have 3 functions that will be helpful to discern these addresses. And if you want to convert, we'll also have a function to convert from an IPv6, an IPv4 mapped IPv6 address to an IPv4 address. And stringify will print IPv4 mapped addresses as IPv4 addresses. If you want to compare addresses, it's, again, straightforward. The only small twist was for handling IPv4 mapped addresses. We just convert them to IPv4 addresses and call a function again. If you only want to compare the address port, the address part, you don't care about the port. We have a function for that, and we also have a function for computing hashes if you want to store addresses in a hash table. Some wrappers for BSD functions that take addresses. They are really thin wrappers. We just take the members out of the address structure and pass them to the BSD function. So that makes it easy to port existing code. We just prefix AST, the AST underscore prefix to existing functions, and any developer out there can reuse his knowledge of BSD APIs. And why do we need that at all? Is just to avoid cast errors. Two cast functions. These are going to be removed in the future. You're not supposed to use them for new code. For existing code that was not to be converted for 1.8, we sprinkled these cast functions all over. Exactly. Sin doesn't mean sin. It means suckadder in. We like the coincidence. That's pretty much it. You have any questions?